Hello and welcome. Today I'm here to talk to you about mass wasting and the factors that influence it the most. Without further ado, let's get right in. The first thing I'm here to talk to you about is what actually mass wasting is. Mass wasting is the downslope movement of sediment and/or rock caused mainly by gravity. The mass part of the name implies that a somewhat coherent group of sediments or rocks begins moving downward due to the force of gravity, and usually in combination with some triggering mechanism such as an earthquake, rapid erosion at the base of a slope. The wasting part of mass wasting means that a cliff or mountain slope is diminishing in size or washing away. This can occur suddenly with tremendous destructive force or very slowly with only a gradual alteration of the Earth's surface over a period of many years. Given enough time and repetition, the different types of mass wasting can play significant roles in reducing a tall mountain to a mound of low rolling hills and wielding a narrow canyon into a broad stream valley. As I mentioned earlier, the gravity is the main catalyst for mass wasting, but there are several other factors that can lead to mass wasting, including steepness and repose of the slope, water content of the soil, the local climate and vegetation, and natural disasters that may trigger mass wasting, such as earthquakes or volcanoes. I will discuss these later in the video, but for now we'll focus on the main factor, which is gravity. The force of gravity is by far the most important factor influencing mass wasting. This is because without gravitational force, none of the other factors would be able to cause mass wasting. In the absence of gravity, all the mass and sediment would essentially just sit there, and since there's nothing to pull it down the hill. However, there is no known place in the universe with no gravitational forces, and here on Earth the force of gravity is a constant 9.81 meters per second squared. This means that gravity will always have a role in mass wasting, and is not a factor that varies depending on the location of mass wasting, as long as it's here on Earth, that is. Aside from the force of gravity, the composition and steepness of the slope is the most influential factor on mass wasting. The makeup of slopes is generally divided into two categories, consolidated and unconsolidated. A consolidated slope is one where the rock and/or sediment is held together by something such as cement. Likewise, an unconsolidated slope is one where the rocks and sediment aren't held together by anything. Because an unconsolidated slope is not held together by anything, all the material is much more free to move, which means it is more susceptible to mass wasting than a consolidated slope would be. Another factor to consider is the slope's angle of repose. An unconsolidated slope's angle of repose is the maximum angle to which the rocks or sediment can be held at without sliding. Most unconsolidated materials have an angle of repose between 25 and 40 degrees. Materials with higher angles of repose are said to have more cohesion, which means they stick together better and will be less likely to give way to something like a landslide. Larger materials such as rocks or boulders lend to have higher angles of repose than smaller materials such as sand. Not all slopes are their angle of repose, but the closer the slope is to the angle of repose, the more likely mass wasting will become. Otherwise, oftentimes slopes with running water at the bottom will be gradually eroded away by the current until the slope reaches its angle of repose, at which point mass wasting takes place. The process will often repeat itself very slowly, but over thousands and thousands of years it can have a drastic effect. One place where this can be seen quite clearly is at the Grand Canyon in Arizona. The river never gets very wide throughout the canyon, but due to the constant the water would wash the stuff away, and then the mass wasting would come in with the angle of repose, which causes mass wasting, and now the Grand Canyon is more than a mile wide in some places. The next thing we'll talk about that affects mass wasting is water content of the soil. Water content is another important factor because in an unconsolidated slope, there are tiny pockets of empty space between the pieces of rock or sediment making up the slope. Water can pass through these empty spaces and influence the slope's susceptibility to mass wasting to varying degrees based on a few different factors. The higher the amount of water present with the slope can decrease the slope's angle of repose and lead to mass wasting. Another factor to consider is the surface tension between the sediment or rock making up the slope. If a substance has a higher surface tension, it is less likely to be affected by the water. Eventually, however, the material can become oversaturated and water will work its way between the pieces and lubricate them, which can lead to mass wasting. A good example of this building is a sandcastle at a beach. Adding a little bit of water to the sand will help it stick together, but not if you add too much water and the sand won't stick together at all and you'll just have a puddle of sand with a mess on your hands. The sheer weight of the water present can also lead to mass wasting. Water is much heavier than air since it's replacing the air in the slope, and the added weight can increase the likelihood of mass wasting. Next thing we'll talk about is climate and vegetation in relation to mass wasting. Both the local climate and the slope is in and the vegetation present on the slope will often influence whether or not mass wasting will occur. For example, slopes in a cold climate will be frozen for part of the year, and when summer comes, they will thaw. When water is in the slope, it freezes and expands by 9% in volume. When the weather warms, the ice thaws, it will flow down and leave the expanded cracks where the ice was. This can often lead to mass wasting in these areas. Slopes in climates that receive a lot of rain will be more susceptible to mass wasting due to the increased amount of water present in the soil. Another factor to consider is any vegetation that is growing on the slope. The roots of the plants will spread out throughout the slope and strengthen it. All the roots of the different plants can tangle together, and this will provide a structural support to the surrounding rocks and sediment. Likewise, if the vegetation is then removed with all the roots, the slope will be greatly weakened and mass wasting is more likely to occur. The next thing we'll talk about is earthquakes and other natural disasters in relation to mass wasting. Earthquakes are by far the biggest one. They're especially known to lead to mass wasting. This is because when the ground gets violently shaken during the earthquake, the pieces of rock and sediment gradually work space in between them. This will often lead to mass wasting in areas near the epicenter. The events can be particularly deadly. There was an earthquake that triggered a landslide in China in 1920 that totaled an estimated 200,000 fatalities. Though none rival the massive number of fatalities the quake in China caused, there are several other places where the earthquake that triggered the deadly instance of mass wasting, including the USSR, Peru, and Ecuador, just to name a few. This often happens in areas with poor soil quality and are densely populated. Though not as common, volcanic eruptions have also been known to lead to instances of mass wasting. The final factor I'd like to talk about today is the human element. It's no great secret that humans greatly impact our environments, both in good ways and bad ways, mostly in bad ways, admittedly. Increased human population has led to widespread deforestation and overfarming all across the globe. Practices such as these greatly influence the likelihood of mass wasting because they greatly weaken the surrounding soil and sediment. This often leads to increased occurrences of landslides in areas that are messed with by humans. There are also some ways in which humans positively impact the environment and seek to reduce the influence on mass wasting that we create. There are many programs dedicated to replanting vegetation on areas where it has been removed to strengthen the soil. And there's also a lot of times if the seawall, the coastline, begins to erode away due to the angle of repose being reached, we'll build a seawall there to help shore that up to reduce mass wasting. That's all I have to share with you today, and thank you for your time.